Hello everybody! In this video we will look at using Python scripts within the CNC machine control software Micro CNC through a laser cutting example. The Micro CNC software is free and can be downloaded from our website. The laser cutting process will be demonstrated on a redesigned version of an older generation 3D printer. The complete control electronics were replaced on the 3D printer. For control, we now use Audium's Automatica ETH MCI motion controller based on Ethernet communication with PC and 4 MST109 microstep drivers for stepper motors. More details about the process of retrofitting a 3D printer and transforming it into a multifunctional CNC machine will be presented in a separate video. Here you can see a bit of the atmosphere during the 3D printer retrofit process. In our example, we will use the 3K20 laserhead to cut the foam. It is a semiconductor laser with an optical power of 20 watts. The laser power is controlled by a PWM signal. The laser module requires a 24-volt DC power source with a minimum current of 5 amps. The control signal and power supply to the laserhead are supplied via a 3-pin detachable connector. The control PWM signal is supplied to the third pin, the second pin is common ground, and the first pin supplies the 24-volt DC for the laser. 2 built-in fans are used to cool the laserhead and the cutting zone and to remove gases from the cutting zone. The laser source is mechanically protected by the laser's housing, and that makes it difficult to estimate the laser beam's position before the start of cutting. There is, however, an LED indicator which roughly shows where the laser beam will hit, but it is not the most convenient to use. Therefore, we will measure how much the laser beam is shifted relative to the laser head's housing, so that we can use the value of that offset when writing our script. By measuring, we determine that the laser beam is shifted 33.5 mm along the x-axis and 24 mm along the y-axis. Since the laser head has a fixed focus, there is a ruler on the side that allows you to determine the distance of the laser head from the surface of the material being cut to the laser. There are 6 holes with threads that are used to mount the laser on the CNC machine. We will use custom-made angled holders to mount the laser. First, we fix the holder to the laser housing. Then, we mount the laser onto the CNC machine using the 2 screws as shown. Finally, we simply insert the connector. Let's take a look at how the PWM signal needed to drive the laserhead is generated and how the laserhead is connected to the control system. For the laserhead, of course, it is necessary to provide a power supply. The PWM signal is generated by the ETH MCI motion controller. We choose the digital output 09, which will be connected to the PWM input on the laserhead. Now it is necessary to configure the Micro CNC software accordingly. Pressing the Setup button will open the Setup dialog. In the Axis Setup, Axis Output Pins option, it is necessary to enable the spindle axis and assign step pin to output 9. Then select the Spindle and Coolant option. For spindle motor control, select PWM out. we must also enter the PWM signal frequency value. The Laserhead's manufacturer recommends 5 kHz, so we will set it as so. It is also necessary to enter the values of the minimum and maximum RPM of the spindle, as well as the corresponding minimum and maximum values of the PWM duty cycle in percents. The duty cycle is the ratio of the duration of the active signal to the duration of one PWM cycle. The duty cycle directly controls the power of the laser. For example, if the duty cycle is 10%, the laser power will be 10%. If the duty cycle is 50%, the laser power will be 50%, and so on. We will simply allow the full range of the duty cycle from 0 to 100%, which are the default values anyway. The value of the max spindle RPM is irrelevant in this setup, so we will simply set it to 10,000 for convenience. Now that the Laserhead is properly set up, let's see how to control it with an example G-code. Let's walk through it step by step. The G0 command performs rapid movement to the coordinate specified. Here specifically, the Laserhead will move to 0 along the X and 0 along the Y axis. In the second line, we perform no action, rather we initialize some parameters. We set the spindle RPM to its maximum value, which is 10,000 RPM, and crucially set the A axis to 0. The hardware is set up in such a way that when the spindle motor is controlled by a PWM signal, the A axis controls the PWM's duty cycle. The A axis can take values from 0 to 0.255. A0 will simply set the laser power to 0, A0.255 will activate maximum laser power, and the values in between will activate the laser to proportional power. M3 simply turns on the laser and M5 turns it off. G1 is a command similar to G0 in that it performs linear movement to the given coordinate, but it requires us to specify the feed rate. So, this whole G-code program will first move the Laserhead to the beginning, then move some distance with 50% laser power, and then move some distance with 100% laser power. Quite simple. Back to Micro CNC, we imported a G-code program similar to the example we just went over. The only difference is that now the laser gradually increases its power until the halfway point, and then gradually decreases its power until the end. We can use an oscilloscope to monitor the actual PWM signal generated by our motion controller. We'll connect the probe to pin 9 and fix the ground. Let's run the program and look at the oscilloscope. As you can see on the oscilloscope, the motion controller generates a PWM signal of exactly 5 kHz, which matches with our configuration. Laser power can also be adjusted using the spindle override function. In this G-code program, the laser power is set to the maximum value, but it can be changed mid-execution by changing the spindle override value like so. We already mentioned that this video will provide an example of writing a user script for laser cutting a piece of foam. The task is to cut out a matrix of m by m pieces with dimensions x and y. We cannot simply write one G-code program like before, because the moment we need to cut out a different shape or change the matrix dimensions, the G-code will need to change. So we need some way to automate this. The new version of Micro CNC offers a solution with the support of Python scripts. Namely, it is possible to create custom macros in the form of Python scripts that can then be called from G-code or directly from the MDI command line. The format of the macro is the letter M, followed by a number that identifies the script, and then .py. One of the functionalities that these macros support is passing up to 4 parameters. This provides us with an ideal solution to our problem with cutting out foam pieces. We will create a macro command that will receive M, N, X, and Y as input parameters, and then generate G-code that will cut the foam into the exact number of blocks of the desired size. As you can see, we decided to call our script M365. Before the script's execution, we need to define the starting position of the laser. The coordinate origin could be set to the bottom left corner of the foam. Actually, let's slightly nudge the origin towards the inside in order to avoid cutting along the edges of the foam. Then we can align the bottom left corner of the laser housing with the origin and define this as our starting position by setting the workpiece coordinates to 0. The G-code program will take into account the already measured X and Y offset values to precisely move the laser beam to the origin before actually starting to cut the foam. Here is the M365 Python script that we wrote, so let's briefly walk through it. There will be a link in the video description where you can find the script. What it does is it creates a file called lasertest.tab, writes some G-code in this file, and then loads the file in the Micro CNC environment. We have some global parameters outside of the file writing block, namely the offset parameters. We know that the parameters are 33.5 and 42, but in our implementation the values should be negative, so let's add the minus sign. The feed rate should not be too high, because then the laser can't penetrate the foam fully, and not too low, because then the work table will be damaged excessively. We experimented with a few different feed rates and found 700 to do just fine. We made it so that you can also adjust the power of the laser by changing this number right here. Here we store the parameters to be used later when writing the G-code to the file. So in our case, this is the M, N, X, and Y parameters that determine the shape of the matrix. In the file block itself, we simply write lines of G-code to the file. You can recognize some familiar lines from before, like turning on the laser with an M3 command and correcting for the offset of the laser with the G0 command. For the cutting itself, our idea was first to cut all the horizontal lines and then to cut all the vertical lines, but to do so in a zigzag pattern to make the least amount of unnecessary movements. You will see shortly how that looks in practice. Exiting the file block, the lasertest.tab file now contains the full G-code program that we would like to execute. This line of code loads the G-code from the lasertest file into the Micro CNC environment. Now we should be ready to run this macro. We're back to the machine, and here's the 10mm thick piece of foam that we will be cutting. Let's now position the laser. Firstly, we will use the laser's ruler to position the foam along the z-axis. The way the ruler works is that it indicates where the focus point of the laser is. 0 means that the focus is at the surface of the material, and 2, for example, means that the focus is 2 mm deep into the material. If we wanted to engrave something onto the material, we would set the focus at the surface. But since we want to cut the piece of foam, the focus should be set at the half of the thickness of the material. So we will gently move the Z-axis until the ruler indicates 5 millimeters. Now we need to position the laser in the XY plane. As we said earlier, the laser's starting position will be where the housing's bottom left corner aligns with the bottom left corner of the foam. Or rather, a little bit inwards. Now, by pressing the 0 all button, this is our laser starting position. Finally, let's call the macro from the MDI command line. We're gonna cut out 15 by 100 millimeter pieces in a 5 by 2 matrix. So let's write M365, L5, P2, Q15, R100 and press enter. Now that the G-code is loaded, simply press the start button and the G-code will start executing. Let's take the pieces out and see how they look. That would be all for this video. We hope you enjoyed it. If you have any questions, ask us in the comments. See you next time.